Good morning, everybody. Thank the Institution of Engineers India to give me a great opportunity to be here. I am actually in awe of the tremendous expertise, depth of talent, and sheer experience of distinguished scientists and members who are here. I'd like to just share a few thoughts on agricultural applications, but it has to do with renewables. The field of renewable energy is the need of the hour, and I think I'm very thankful that Institute of Engineers has organized this particular panel session on governance and other issues, which are basically what I have been trying to highlight. This is not so much a technical session as much as how can we get society to benefit and how can we get the governance to make sure these things happen. Our background, I'm a mechanical engineer from UEC 76 batch. One of my classmates is here. And I got my MBA from Clarkson University, upstate New York, back in 78. I have been living in Silicon Valley from 83 onwards. Ran my own engineering company from 83 onwards today. And I'm a past president of the Institute of Industrial Engineers in Silicon Valley. And I'm listed in many forums, international who's who of professionals in New York and many places. Most of my work has been through semiconductor industry, through infrared thermography, which we are one of the pioneers in the world. We have patents and processes in that. Applications in semiconductor, basically temperature technology is very crucial in electronics. It can either make or break the product. Even operating products can stop, fail, or be completely destroyed by heat, except with no other factor being involved. Matter of fact, what this little picture highlights is a representative of a exposed part, inside a chip where those crosshairs indicate the highest temperature. That is a critical factor in measuring the long-term reliability. If the temperature at that point inside the chip goes 10 degrees above its rated or normal value, the long-term life of the chip goes down by a factor of 10. So if the life of the chip is 10 years, it will survive only 1 year. So that is the crucial value of infrared imaging, and we developed this technology back in '82. Some of our customers are Sun Microsystems. We were the company that did the thermal coil on the first servers that launched the internet to the world. Also, did the work with many other pioneering companies. Power Integrations, which does energy efficiency at a chip level. They hold an International IR 100 award. Some of the research behind testing product development was done at our labs, Sealink Labs in USA. And with Intel, AMD, National, we have done consulting with a lot of different companies. Just a few background, we have done work with National Semiconductor, Hewlett-Packard, Cisco, NASA, then Chip, AMD. Lumileds, a lot of work with LED lighting. And NVIDIA, we did the GeoForce series high power graphic chipsets. LGS Thompson and Hitachi, many companies. Coming to present, we shifted from semiconductor testing to renewable energy because of the recession from 2000 onwards. It affected a lot of industries and companies and economy not only in the Bay Area but entire United States. It's crippled a lot of the electronics industry. What is relevant here, just to highlight why we want to look at this field. India loses approximately 30% of its gross agricultural output in food grains, fruits, vegetables, produce, for no other reason other than that we have a lack of storage. We have a lack of cold storage, we have a lack of proper warehousing. So warehousing alone is about 45,000 crore loss. And I think this is a criminal loss. I have brought it up before some members of parliament also. And I think this is not rocket science. And it is a really sad reflection of the country that with great difficulty the farmers grow whatever they grow and whatever they bring to the market. And it's like, you make 1,000 new nano cars and bring it to the front of the street and just burn it and throw it away. It's equivalent. Just to give you an analogy, that kind of a loss, people don't recognize the loss because it is in the interior, it is in the rural area. All the same, this is an important factor, and this is going to be a more critical factor in the future because of the growth in population and migration of people from villages. As it is, Bangalore, we have seen so many newspaper listings about why the vegetables, fruit costs are going up. Now, we intend to bring solar technologies to improve quality and productivity into Indian agriculture, which is crippled by lack of basic machinery and tools. I was recently speaking at another forum in agriculture with another Indian multinational, which is one of the largest exporters of gherkins out of Karnataka, out of India. I directly spoken to a lot of farmers. It was the first experience for me to meet and directly talk and interface with farmers. And I came to learn that the productivity is so low in India because they don't even have simple tools. And it is really pathetic that after 50 years, 60 years of independence, our science and technology is so skewed. We put a man on the moon, or we can put a rocket up around the moon. And hats off to ISRO for their awesome expertise that is recognized throughout the world. At the same time, we are not able to take care of very simple things. The other goal is to reduce major losses in power use and transmission losses in IP sets. Yesterday, Mr. Selva Kumar, Managing Director of KPTCL, addressed this issue. So that's one of the intents behind the formation of the Solar Agriculture Institute of India. So we intend to bring cost-effective innovations, including low-cost warehousing, that is utilizing local resources and warehouse. We can, to give you a very simple example, we got maybe a couple of lakhs of telecom towers throughout the country. What has been done is this equipment has basically been put into a shed with absolutely no concern about the heat. So once the heat is generated from the equipment, you have to put a bunch of air conditioners and coolers. And to me, this is a very simple solution. If there were simple air vents at the bottom and top, the natural airflow will reduce the need for the cooling quite considerably. And this is a simple thermal solution. But anyway, those are some of the things. Coming to one particular issue in sustainable agriculture, we have so many different sources of water, canal, wells or bore wells. What is that? To size a unit and how much solar panel do you need to put there? These are the factors that you need to consider. Number of hours per day, storage available in the tank, facilities for drip irrigation. By the way, drip irrigation is not as common as I thought it was, and it was a revelation to me when I spoke to the farmers. A lot of farmers still don't use drip irrigation, either because of the lack of funds and or they think it is not required, but it is a requirement because water shortage is so tremendous. I think other members on our panel will address that also. This is a sustainability issue. Then going to more technical detail, we can go to whether you need solar power with different inverter or AC pump, DC pump, what are the controllers and what are the size of the pump. There's just a few pictures just for representation. I understand the state of Rajasthan is leading in India. They have done a lot of progressive developments for the farmers, and a lot of pumps have been effectively used. And I'm sorry to hear that this is not the case in Karnataka, and we hope to make some difference there. And it's not just solar water pumps, we are also talking of solar grain drying. It's very innovative way. A lot of grains are dried in the villages by just spreading the grain on the road. Cars and buses go across and it pulverizes the grain, and also all the germs get in. So you lose a lot of grain right there. At the same time, you add impurities to it. Whereas if you put a simple grain dryer with solar, it doesn't take too much energy, but the power of the sun is used for drying. And I think this alone will be a huge factor where I feel the expertise of Mr. Hande would probably give us a good insight where else we can do this. There are many other rural solar applications for lighting, etc. And again, this is well known as far as lighting is concerned. This is just a slide to show what is our idea. From California Golden Gate Bridge to the fields of Karnataka and India, Golden Gate to Golden Fields. That is our motto. Hopefully we'll be able to do something with it. And yeah, I'd like to just share one other slide here. That is the I'd like to highlight this particular picture. You can just
Dr. A. Prasad is here. Okay. You take. Sir, you are required in the main hall, it seems. This person will take you there. Sorry, sir. Thank you.
I put this poster, I designed this poster for ITC for this particular session, just to give you a glimpse of the world of renewable energy. Starting with solar, on the left hand side there is solar impulse plane. A country like Switzerland, a small little country like Switzerland, has designed and developed this solar impulse, which is today one of the world leading aircraft. It is currently in the United States today. It is going around the United States. And this pioneering aircraft has flown more than 24 hours continuously, completely powered by solar. It is hoped that this will be a precursor to the future of the solar and bring the solar technology to transportation, which uses a massive amount of fossil fuels. Below here we have the planet Turano Solar. This is also a very leading and a very revolutionary ship for the first time in the world. It has circumvented the globe. This was launched a year ago, and this is also currently, it was in New York a month ago. This, just to give you an idea, what is the amount of fuel used by ships. Ships use a staggering amount of fuel, and not only using the fuel, it also pollutes the ocean. This technology and what they have done with this technology is they have used like a catamaran style base, which makes the ship lighter and gives a wider base, and thereby making it lighter for, you put solar panels on top. As and when the efficiency of the solar panels grows up, this can be used very effectively for a huge portion. You may not be able to completely eliminate diesel power, but at least you can significantly reduce it. Even if the world can reduce 10%, it's going to be a big deal. At the bottom down here we have the Mahindra E2O car. It's also revolutionary. It's too high cost for right now, but we expect it to come down. There are companies in the United States, the Tesla car for instance, which runs on batteries, and they are looking at solar options. This will also be a major energy saver and current saver. The top 5 circles, wave energy, solar energy, wind energy, biomass and hydro, those are all different renewable sources, and in any state, any country, you need to get a balance, and this is where some governance also comes in, to judiciously use what is feasible in that area. In the desert, you cannot use hydro, and by conversely, if it's in a very cold country, maybe you have better opportunity for biomass or wind. As a matter of fact, biomass is even used in Switzerland, even for the waste removal and recycling. And I think this is something Bangalore can look forward to. I understand there is a company here that was mentioned in last SolarCon and one of the recent solar energy conferences by the Chamber of Commerce. So anyway, I just wanted to get a glimpse of see the total spectrum where renewable energy can be created and where are the users. Users in the black circles at the bottom, the transportation, HVAC, heating, ventilation, air conditioning, and lighting. LED lighting is a good opportunity, and again I am extremely honored and feel it's a great privilege to be here, where the hometown of Seram Visheshwaraya. We hope to do some projects in the area for helping the rural populations, and that's it. Thank you. Any questions?